Section 12.1, Complex Numbers. Here we have the complex plane, which consists of the x-axis, which is positive numbers, positive real numbers, and the j-axis, which are your imaginary numbers. J is equal to the square root of minus 1. J times j is equal to minus 1. J times j times j is minus the square root of minus 1, or minus j. J times j times j times j, since j times j is minus 1, it's going to be minus 1 times minus 1, which is a 1, and then it repeats. So if you have the square root of negative 36, prior to this section, we would answer no real number. But now we can separate out that the square root of negative 36 is the square root of 36 times the negative square root of 1. Square root of 36 is a 6, and the square root of negative 1 is a j, so your answer would be 6j. Square root of negative 48 is going to be the positive square root of 48 times the square root of minus 1. 48 is 16 times 3. 16 is a perfect square, so that's a 4 comes out of that. So that would be 4 root 3. You still have the square root of minus 1, which is j, so you put the j with the 4 that came out, so that's equal to 4j root 3. Square root of negative 25 over 4, this is equal to the square root of 25 over 4 times the square root of negative 1, which would be square root of 25 over square root of 4 times the square root of minus 1. Square root of 25 is 5, square root of 4 is 2, the square root of negative 1 is a j, so there would be 5/2 j. If you have a minus out in the front of the square root of minus 100, the minus out in the front pretty much stays out in the front. So when you take the square root of 100, you get 10. The square root of minus 1 is a j, so it would be minus 10j.